Students, today we start unit 3 network layer in computer networks. So first I explain the design issues of network layer. The first design issue is IP addressing and second design issue is routing. Now first I explain what is IP addressing. An IP address is an IP address used to uniquely identify a device on an IP network. The address is a 32-bit bit IP address which can be divisible into a network part and the host part. The 32-bit IP address is divided into 4 octets. Each octet is converted to decimal and separated by the dot operator. For example, 192.168.10.10. There are two versions of IP address. First one is IP version 4, second one is IP version 6. IP version 4 size is 32-bit and in IP version 4 it contains 2 to the power of 32 unique addresses. Second is IP version 6. The size of IP version 6 is 128-bit and it contains 2 to the power of 128 unique addresses. Now first we talk about IP version 4 addresses. The types of IP version 4 address. First type is classful. Second type of IP version 4 address is classless. Now first we talk about the classful addressing. The IP version 4 classful addressing is divided into 5 subclasses: class A, class B, class C, class D and class E. Here class A, B, C are used for unicast, class D used for multicast and class E is reserved for research and experimental purposes. IP version 4 further divided into 2 parts. First part is called network ID, second part is called host ID. Based on diagram, class A first octet or first byte is called network ID and rest of 3 octets are called host ID. In class B, first 2 bytes work as a network ID and rest of 2 bytes work as a host ID. In class C, first 3 bytes work as a network ID and last byte work as a host ID. In class D and class E, no further distribution between network ID and host ID. Now the binary notation and dotted notation of classful addressing. In first we talk about class A. Class A is identified using 0 bit. The first bit of class A address if it starts with 0, we can say that it is a class A addresses, and the range of class A address starts from 0 to 127, but 0 and 127 is fixed for some specific purposes, so we can only assign the range between 1 to 126. Now in case of class B which is identified with 10, means 2 bits are used for identification. That's why the range of class B starts from 128 to 191. Similarly in class C, that is identified first 3 bits, that is 110. If first 3 bit is 110, it is a class C address. The range of class C starts from 192 to 223. Class D is identified with the first 4 bits, and if first 4 bit value is 110, it is a class D address. Its range starts from 224 to 239 in decimal notation. Similarly, class E is again identified using first 4 bits, but the first 4 bit should be 1111, and the range of class E address starts from 242 to 255. Now the further I divide the classes based on the number of addresses, space available, number of networks we can create, number of hosts and the default subnet mask for each class. So based on this table, first class A is identified the leading bit 0. So total number of addresses, IP addresses are available in class A, that is 2 to the power of 31, and the range of class A is 1 to 126. Number of networks are available 2 to the power of 7, because from net ID, first bit is for identification, rest of 7 bits is used for creating the network. But we cannot use 0 and 127, that's why the number of networks available 2 to the power of 7 minus 2. Similarly, how many number of hosts available in class A? The host bits are 24 bits. You can create 2 to the power of 24 number of hosts, but we cannot assign the first and last address. The first address is reserved for network address, last address is reserved for broadcast address. So that's why we subtract minus 2. And the default subnet mask for class A is 255.0.0.0. Now in class B is identified first 2 bit is, if first 2 bit is 10, and number of IP addresses available in class B is 2 to the power of 30, means less number of addresses or space available in class B. And the range of class B starts from 128 to 191. Number of networks, the net ID that is available in class B is 16 bits, but first 2 is used for identification, rest of 14 bits used to create the number of networks. So we can create in class B 2 to the power of 14 networks, and 16 host bits are available in class B, so I can create 2 to the power of 16 host. First and last address we subtract, that's why minus 2. And default subnet mask of class B is 255.255.0.0. Now in class C, that is identified first 3 bits. If first 3 bit of IP address is 110, means it is a class C address. Number of addresses available in class C is 2 to the power of 29, because 3 bits used for identification. Range of class C starts from 192 to 223. Number of networks available. Now number of network bit that is available in class C is 2 to the power 24, but 3 bits are used for identification. I can create only 2 to the power of 21 networks. And 8 bits are available for host, means we can create 2 to the power of 8 hosts, but we cannot assign first and last address, that's why minus 2. And the default subnet mask for class C address is 255.255.255.0. In case of class D, we can identify it using first 4 bits, that is 1110. Number of IP addresses available in class D 2 to the power of 28, and the range of class D is 224 to 239. Now in class D, number of networks and number of hosts are not defined, especially not defined the default subnet mask also. In class E, is first 4 bits for identification is 1111. So same number of IP addresses available in class E, similar to class D, to the power of 28. But the range is 240 to 254 is for class E. And number of networks and host and default subnet mask is not defined for class E. There are some special addresses available. The first range is 169.254.0.0 to 169.254.0.16, used for linked local addresses. Second series 127.0.0.0 to 127.0.0.8, used for loopback addressing. Last series 0.0.0.0 to 0.0.0.8, used to communicate within the current network. Next, some addresses used for public addresses, some are used for private network. For private network, series of class A is 10.0.0.0 to 10.255.255.255, means to the power 24 IP addresses of used for class A private addresses. Second, class B private address series is 172.16.0.0 to 172.31.255.255, means it contains to the power 20 IP addresses. If I Next series for class C, that is 192.168.0.0 to 192.168.255.255, means it contains only 2 to the power of 16 IP addresses. So if less number of IP addresses are required, use class C series. If more number of addresses are required, then use class A series. So home used wireless routers basically always use the class C series 192.168.1.0/24. In class full IP addressing, a large part of available addresses were wasted. Class full addressing, which is almost obsolete, is replaced with classless addressing. Now we talk about the classless addressing. In classless addressing, that is represented x.y.z.t similar to classful addressing, but /n, where /n is called the CIDR notation. Usually xy.z.t is the first address in the address block. Okay, thank you students.